Hi, this is Melanie Fine with Chem in 10, and today I'm going to teach you how to draw Lewis dot structures. We're specifically going to focus on Lewis dot structures for covalent molecules. The first step is you find the total number of valence electrons. Then you arrange the atoms so that the singular atom is in the middle. You form bonds between the atoms. Each bond takes up 2 electrons. Each single bond, that is, takes up 2 electrons. And you distribute the remaining electrons to give each atom an octet, a full outer shell. When I say recall exceptions, what we're talking about right now is that hydrogen and helium only have 2 electrons to fill up their outer shell, but most other elements need 8. And then if there aren't enough electrons to go around, form double or triple bonds. So let's look at an example. Carbon tetrafluoride. Carbon is in the 4th column of the representative elements. The tall 4th column, it actually says 4A at the top. So that means it has 4 valence electrons. And each fluorine atom has 7 valence electrons because it's in column 7A. All the halogens have 7 valence electrons. So we have 1 carbon, which has 4 valence electrons, and 4 fluorines that have 7 valence electrons each, for a total of 28. Add that together and we have 32 electrons to deal with. We arrange the atoms so that the singular atom is in the middle, the carbon, and then we form the bonds. Each bond takes up 2 electrons. So we've just used 8 electrons to form the bonds, so we have 24 electrons left to go around to make sure everyone has a full octet. Carbon already has a full octet, so let's fill up the fluorines. I just filled it up with 24 electrons, and this is our Lewis dot structure for carbon tetrafluoride. Often we use lines to represent the bonds, so we can replace the bonds with lines, and it's the same thing. Or replace the electron pairs that are shared, the bonds, with lines. So that the lines mean a covalent bond. So this would be the Lewis dot structure of carbon tetrafluoride. Notice that the lone pairs on the fluorines, the extra electrons, are still indicated in the Lewis dot structure. You need to indicate electrons that are not involved in bonding. Let's look at another example, H2O, water. Water has 2 hydrogen atoms, and they each contain 1 valence electron, and 1 oxygen atom that contains 6 valence electrons. So we have 2 valence electrons from the 2 hydrogen atoms, and 6 valence electrons from the 1 oxygen atom for a total of 8 valence electrons. We draw the elements so that the singular atom is in the middle, and next we draw the bonds. So we have a bond between each hydrogen and the oxygen. So we've used 4 electrons to make the bonds, so we have 4 electrons to go around. Remember that hydrogens are full when they have 2 valence electrons, so the hydrogens are already full. So we need to fill up the octet of oxygen, so we add our 4 electrons around oxygen. So that would be the Lewis dot structure of H2O. And again, we can replace the bonding electrons with lines if we wish, but remember the lone pairs still exist and we still need to draw them in the Lewis dot structure. The lone pairs on the central atom will play an important role in determining the shape of this molecule. Let's look at one more example, carbon dioxide. Carbon has 4 valence electrons and there are 2 oxygens. Each oxygen atom has 6 valence electrons for a total of 12 valence electrons. So we have 16 valence electrons to work with. We draw it so that the singular atom is in the middle of the carbon, and next we add our bonds. Each bond uses 2 electrons, so we've just used 4 electrons, and we have 12 electrons to go. So we'll distribute the remaining electrons so that everyone has a full octet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the oxygens have full outer shells, but carbon, if you notice, only has 2 bonds, which is a sharing of 4 electrons. So carbon needs 4 more electrons. So when we don't have enough electrons to go around, we form double or triple bonds. The way we do that is we take an electron pair from the oxygen and double up the shared pair between the carbons. We do that on both sides, and now we have oxygen has 8 electrons. It still has 8, but now 4 of them are involved in the chemical bond. That would be a double bond because a single bond is 2 electrons, a double bond would be 4 electrons. Carbon now has 8 electrons. They're all involved in bonding, and oxygen has 8 electrons. So this is the Lewis dot structure for carbon dioxide. Again, we can replace the bonding pairs with lines for bonds. So notice that double bonds, we draw double lines. And again, we keep the lone pairs intact. One more example, hydrocyanic acid or hydrogen cyanide. To find the total number of valence electrons first, we have one hydrogen, that's 1 electron, one carbon, that's 4 electrons, and one nitrogen is 5 electrons, for a total of 10 electrons. Since we only have one of each, we'll just draw it linearly, H, C, and N. We'll draw our bonds, 2 electrons each. We've now used 4 electrons, so we have 6 electrons left, and we'll distribute the remaining electrons. Hydrogen is already full, by the way. 1, 2, 3, 4, 5, 6. So now hydrogen has a full outer shell, and so does nitrogen, but carbon doesn't. So again, let's take a lone pair from the nitrogen and double it up. So now we have a double bond between carbon and nitrogen. Carbon now has 6 electrons, nitrogen still has its 8, so it's getting better, but we're not finished because carbon doesn't have a full outer shell. So we'll take another electron pair, a lone pair from nitrogen, and form a triple bond. Now, hydrogen has always had a full outer shell. Carbon now has 8 electrons around it. 2 of those electrons are involved in the bond between hydrogen and carbon, and 6 electrons are involved in the triple bond between carbon and nitrogen. And nitrogen also has 8 electrons, 1 lone pair, and 6 electrons involved in bonding. If we were to place the bonding electrons with lines, it would look like this. Triple bond would have 3 lines. And again, we leave the lone pair intact. I hope you enjoyed this video. To get more chemical bonding help and a free gift, go to purplebonding.com. That's purplebonding.com. This is Melanie Fine of Chem in 10.